Hello, philosophers. This is 1.5 classical logic conditionals. Conditionals are things moving. Oh, there it is. Conditionals are things that relate a proposition to another proposition that depends on it in some sense. It's for example, if then, right? If antecedent, then consequent. Right? So if you have something here, then you'll have this thing over here. So we've already learned about this in philosophy. You may be in logic class. You may be wondering, why are we talking about it some more? Um, this lesson is going to be to introduce you a little bit to the philosophy of logic, right? Um, a lot of times when people are first introduced to logic, they're told that if then is the same exact thing as this guy right here. Every time you have an if-then statement in English, you have one of these guys right here. And, there are some, like this says right here, note one, some if cognates, like we learned in class, the unless, right? Uh, I will not do A unless B, right? That's sort of an if-then, right? If B happened, then A happened, is something like that, right? Also, not every if, there's some ifs that are clearly not if-then statement types of ifs, but for the most part, we learned about the if-then. Now, that's actually super problematic. There's a whole lot of debate in philosophy about um, about the conditional. It is honestly right now it is a wreck. People in logic are trying to figure out how does this guy actually relate to the if-then in English. All right, so we'll call this the material conditional. Um, I will call it from here on out. I'll say that this A materially entails B. And afterwards, I'm just going to say, after this video, I'm just going to be saying if A then B. The reason being because for the most part it works. There's some major problems with it, but for the most part it works. Um, and yeah, so I don't want to constantly be worried about this specific issue, but I do want to kind of introduce you to one of the issues that we have in philosophy. So the A materially entails B. Well, what happens with this guy right here is if you assign the truth values to these guys, then the truth values you'll find out equal the truth values for not A or B, right? So here's what I mean. Remember when we did these truth tables, we say like this 1 0 1 0. I'll assign the exact same truth values to both sides. Be consistent in assigning the truth values. And I'm going to run through these rules really quickly, and I'm going to show you how this actually equals this. So the not A equals 1, this equals 1 if the A equals 0. So here A equals 0, so this equals 1. And if A does not equal 0 otherwise, then not A equals 1. So I did that backwards, didn't I? No, I did that right. Yeah, good. Alright, and then looking at the OR statement, if one of the two, A or B equals 1, then the whole thing, A or B equals 1, right? So now I can't look at the A over here, I have to look at the not, right? So, because I'm saying this is the thing, it's not A or B, right? So I'm looking at the not to see if that set equals 1. So this is 1 right here. Both of these are 0, so this is 0. This one is 1, this one is 1. So that's what it looks like, 1 0 1 1. Now for this one, we have the rule here, it equals 1 if A equals 0 or B equals 1, and otherwise it's 0. Well, so there's only one other case that where this thing will equal 0, and that's if A equals 1 and B equals 0, which is this one right here. Right? That's the case where neither one of these are satisfied. A does not equal 0 because A equals 1, and B does not equal 1 because B equals 0. The rest of the time, A equals 1, right? Because here, let's see, B equals 1 here and here, so these are both 1. A equals 0 here, so this is 1. And now if you look at the middle one here, that shows you what's the truth value for the whole thing, right? You will see that they are actually identical. But that leads us to some problems, right? So remember, not A or B equals at least one of these is true, right? So if not A is true, then not A or B is true. And if B is true, then not A or B is true. So if either one of these guys in here are true, then this whole thing is true, and then that means that this whole thing is true too, right? Because they're identical. So what that means is therefore dot dot dot. Therefore, if not A, that entails that if A then B, right? Because if this one is true, then that entails that this one is true. This entails that this is true, which entails that this is true. So all I need is not A to get this guy going, and all I need is B to get this thing going and then this thing going, right? So B entails that. So either one of these entail the whole thing. The problem with that is, as we'll see on this page, here's what we just proved, right? The problem with that is, it seems like if that's the case, as long as I have something false for A, right, not A, something that's false, I could put whatever I want in B. And as long as I have something true for B, I could put whatever I want in A, right? And we said that the conditional seems like, well, at least the English conditional seems like one depends on the other. But now I'm saying that I can just be totally arbitrary. So for example, if New York is in New Zealand, which is the false A, then 2 plus 2 equals 4, which is the true B, right? So here I used both of these and I got some totally bizarre if-then statement. Here's another one. If New York is in the US, then World War II ended in 1945, right? Here I have a true B, so therefore I have a true if A then B, right? If New York is in the US, then World War II ended in 1945. But boy, that doesn't sound like what I mean when I say English conditional. Support 3, if World War II ended in 1941, then gold is acid. Now this is a false statement, false A, right, not A. So then that would mean that this is a true statement. But again, this seems totally bizarre. Therefore, the material conditional, this is the objection. The objection is, therefore, when we say A materially implies B, that does not equal if A then B, right? This can't equal these guys down here, because that just seems bizarre. So it's a pretty good objection. One response that somebody, a guy named Grice, came up with is from Conversational Implicature. Now what that means, that ugly term means, conversational obviously means conversation, like talking, right? And implicature means imply, like what does what I say imply? So the first thing he says is communication is governed by practical rules. Now this is pretty much a given. This is true, right? There are some rules that when we talk, we just use. I don't know if Grice's exact formulation of them are correct, but at least he's somewhat correct. So for example, he says, one of our rules is to assert the strongest claim. Excuse me. Now what this would be is something like this. If I come upon an accident and I see that somebody has been drinking and driving, and you say, what caused this accident? And I say, well, someone was driving. You're going to think, no, that's not right, right? Something's wrong there. Well, what I'm saying is not false, right? Somebody was driving, and that's part of what caused the accident. But I didn't make the strongest claim I can make. It was a drunk driver that caused the accident. That's what that's what the cause was, right? So although I wasn't saying something that was false, I wasn't totally giving you the strongest claim. So in a conversation, you will say that what I implied was false, or wasn't totally correct. Another rule would be to be relevant. So, for example, if I say, if you show up late to class tomorrow, and I say, hey man, what happened? And you say, oh, we had spaghetti for dinner last night. I'm gonna be sitting there thinking, what? How does that apply? Right? I'm going to be trying to make sense of that. Like somehow your spaghetti dinner interfered with our class. But if you're being totally irrelevant, then you've broken the law of our conversation. Right? So conversation goes by some rules. There are a lot more rules, but we just need a couple examples. So this person would claim that the counterexamples are true. So these things are the counterexamples, right? These are the counterexamples to making A materially implies B equal if A then B. The counterexamples are true, but they violate these rules right here. So in other words, there's nothing wrong with these, they just sound weird to your head because they're violating the communication rules. Therefore, the material conditional does equal the English conditional. And maybe you think that's a good response, but there are a few other objections that won't work for. So for example, objection 2. Some conditionals have the same antecedent and consequent, but different truth values. So, for example, some English conditionals, oh yeah, that's what this says basically. So, for example, if Oswald didn't shoot Kennedy, then somebody else did. True. If Oswald hadn't shot Kennedy, then somebody else would have. False. Right? So it looks like everything is the exact same except for the mood and tense. Right? Past tense, different mood. This is a counterfactual. This is not what happened. Right? And this is a statement of what did happen. I guess it isn't a tense. It's just totally a mood. Yeah. Therefore, both cannot be material conditionals. So in other words, they're both if-then statements, but one is true and one is false using the same stuff. So one of them can't be the materially implies kind of conditional. Well, a response that somebody gives, response one, would be that, well, you're talking about subjective or counterfactual versus indicative conditionals. So subjunctive conditionals or counterfactual conditionals are counter to the facts. That's this one right here. A conditional where you use the word would, right here. Right? And in this conditional right here, this person is going to say, this is not the material conditional. And the reason being because this is false even though the antecedent is false. So remember, the whole deal with this is not A implies or entails if A then B, right? But this has a false A. This is not A. Oswald hadn't shot Kennedy, but he did shoot Kennedy. So this actually should be a true statement, but it's not, right? So this person would say, yeah, well, this is not a material conditional true. This one still can be a material conditional, right? Indicative is fine. It's just that these weird ones are false. Now, that is a good response. A couple of objections to that is that, number one, that there's no grammatical justification for this claim. When you look at these two, it's not it's the tenses or the moods of the verbs, and it's not the if part that makes the difference, right? So when I look at the grammar, I still can say, yeah, but it's an if-then statement, and what's changing the if-then statement is what's inside of the if-then. It's not the if-then itself, right? So I don't have any grammatical justification for this claim. If you study philosophy of language, this isn't a very good objection, I don't think, because a lot of times you have to translate what people mean by if-then. It's not always perfect, right? So just because there's no grammatical justification for this claim, to your ear you may hear it differently. There's something communicated that's differently, and you can pick up on that. And it does seem like the if-thens are then different, but I don't know. Maybe I'm wrong. Objection 2, though, the only difference is from time of evaluation, right? There's no difference between present tense conditionals. If I give you this, if I shoot you, then you will die. Or if I were to shoot you, you would die. Here we go. You will die, you would die. Right? These are both present tense. Oops, sorry. These are both present tense. So they said there's no difference between the present tense conditionals. Both of these are true, and the difference is the time of evaluation. Not sure if I buy that one either, but there are some better objections which come here. So there are 3 more objections we've got, and these are 3 pretty good objections. Based on our rules that we laid out, this is a valid statement. A and B materially implies C. Therefore, if A materially implies C, A materially implies C, or B materially implies C. So what it's saying is, this whole guy materially implies this guy, so this one implies this one, or this one implies, one of these two implies this one. Right? That's valid using our rules. However, when we take that same exact form and translate it into English, sometimes you get this weird stuff, right? If you close switch X and switch Y, the light will go on. Let me show you. Here's a diagram of an amazing diagram of a light bulb. Wow, that is a loop for a light bulb. And here's some switches. And you need to close the circuit in order for the light bulb to come on, right? Well, here is switch X, and here, X, and here is switch Y. Now, in order to get this light bulb on, you have to close both switches. So, if you close switch X and if you close switch Y, then the light bulb comes on, right? Based on this form, though, you can make it to if you close switch X, then the light comes on, right? Which is false. Or if you close the switch Y, the light bulb comes off, also false, right? You need to have them both. So, using this form, I can come up with this same English form, and it's false, even though it's valid up here. I'm not so sure. I'm not so sure that works totally, because it kind of seems like A and B, these two propositions, can't stand by themselves, right? If you close switch X, then the light will come on. Seems like one whole proposition. And if you close switch Y, then the light will come on. It seems like you have to put it that way. I don't know that I totally buy that. In other words, like it seems like to me like you can't say this. You have to say this. If if you close both switch X and switch Y, then the light will come on, right? But I don't know. Smarter people than me have given this objection, so maybe I'm wrong. So there's the objection that material conditional can't equal the English conditional. All right. Here's another one. A materially implies B, and C materially implies D. Therefore, A materially implies D, or C materially implies B. Right? This is valid based on the rules that we've given. I won't go through a full, expression of that. I won't do that for you, but you can trust me on this one. Unless you want to do it yourself, which is totally fine. So this is valid, but let me give you something of the following form, which is exactly the same as this. If John is in Paris, A, then he is in France, B. So this is A, B. And let's say it's like this, right? Like this guy up here. And if John is in London, then he is in England. And C, D. Therefore, it is the case that if John is in Paris, then he's in England. A, D. And if John is in London, then he's in France. This is an or here, but and would work. It's just the same. And where is it? Well, I mean, I could put an or here. I guess that wouldn't be a problem either. That would be saying weird stuff. A, or this should be a D, right? I think it looks like a B. And C, B. Alright, so this is clearly false, yet this was valid. So the material conditional cannot equal the English conditional. Finally, you have this guy. Now this guy is pretty easy to prove, I think. So I'll just very briefly prove it to you. Remember that that A materially implies B equals not A or B, right? And this is true if at least one of these two things are true, right? And so this is false. Let's say this thing is false if both of these things are false, right? Because we're saying that this one on the inside means that at least one of these are true, and so if it's false, it's not the case that at least one is true, right? So if not the case that at least one is true, then not A is false and B is false. So that equals not A is false, which is A, and B is false, which is not B. So if you have this guy, then you have this guy, and part of this guy is this one right here. So that's this, right? So that's valid, and the following of the same form is false. It's not the case that if there's a dog on the road, then it will get hit, right? If A, and then material implies B. Let's pretend that's true. Then there is a dog on the road, therefore A. There's a dog on the road, right? I just showed you this is a true statement, and does that prove that there's a dog in the road? Well, obviously not, right? So therefore the material conditional does not equal the English conditional. Alright. Now you may wonder, if there are all those problems, then why in the world in the first place did we say that if A then B is the same thing as the A materially implies B? Well, some people have fought back, and here's an argument to say that if A then B is true, if and only if A materially implies B is true. Right? So let's see this argument. Here's the way this argument is going to work. First, we're going to prove the one side of it. If A then B is true, if A then B is true, then A materially implies B is true. But we're going to do it using this, because remember, this equals this. Right? These two are equivalent. So we're going to prove one side of it. If A then B is true, then not A or B is true. Then we're going to prove the other side of it. If not A or B is true, then if A then B is true. And then we'll have this statement: if A then B is true, if and only if not A or B is true. So remember, this is what I'm talking about. Remember, this and this equal this. If A then B, if B then A if and only if B. Right? You put these two together and they equal this. So that's what we're going to try to prove the first one, then prove the second one, and then we'll have our last one. So if A then B is true, then not A or B is true. Let's assume that this is true, right? Assume this first part is true. If this is true, then either not A is true or A is true, right? Either one of these two is true. And what we're going to show is, if you have this one, then because this is going to follow from either one of these, then this follows, right? Excuse me. So let's assume that not A is true. Here, this is going to be like a little mini proof right here, starting right now. Let's assume not A is true. Then not A or B is true, right? Because this means at least one of these two things are true, and we just said not A is true. So then this still thing is true. So if not A is true, then not A or B is true. All right, so we have that little mini proof right there. Now let's assume that A is true. Well, due to this, if A then B, right, then I know that B is true. So I know that not A or B is true, because if B is true, then not A or B is true. This is saying at least one of these two things is true, and I just said this was true. So if A, then not A or B is true too, right? Actually, this should include 1, because I used 1 up there. So right, 1 and 6 through 8. So based on this, the fact that either not A is true or A is true, and this, if not A is true, then not A or B is true, and this, if A is true, then not A or B is true, I get this. Right, so what that means is, remember, this is saying one of these two things has to be true, and these two are saying if either one of them are true, then this is going to be true. So therefore, I have not A or B is true. So therefore, if A then B is true, then not A or B is true. We just proved this guy right here. But now we're not done. We have to prove we have to prove the opposite, right? If not A or B is true, then if A then B is true. So let's do that. This first argument is going to use a little bit of I don't know about questionable, but at least a debatable statement. If A then B is true, if there are some true statements C, such that C and A together, from C and A together, we can deduce B. So here's an example. Let's say A equals Oswald didn't kill Kennedy. C equals Kennedy was killed by someone, and B equals somebody else killed Kennedy. So I can deduce B from A and C. Right? I could say Kennedy was killed by someone, and Oswald didn't kill Kennedy. From these two, I can get, therefore, somebody else killed Kennedy. Right? So if Oswald didn't kill Kennedy, then somebody killed Kennedy is true. All right. So that's that. That's I'm saying that Oswald didn't kill Kennedy is A. Somebody killed Kennedy is B. I got this from this right up here, so I needed A and C to get this thing. All right. So then they'll say, then that's this statement that we just proved. So now let's let C equal not A or B. This is a statement we're going to use. We're going to just define C as this statement right here, not A or B. Now, if I assume C is true and I assume A is true, right, I can deduce B from that. Right? Just remember what we said was there's some true statement C from C and A together that we can deduce B. Well, if C is true and A is true, then I can deduce B, right? Because if A is true, then not A is false, and this C said that at least one of the two are true, so that must mean B is true. So that means if A then B is true, from this, and this, right? Therefore, if not A or B, this one right here is true, if C equals not A or B, right? Then if A then B is true, which are proved. So we prove number 2 now. So therefore, if we prove this one and we prove this one, we've also proved this one, the if and only if statement. So there it is. That is the one argument for why conditionals work. Again, this is highly debated in philosophy of logic. I'm showing it here to you so you can understand some of the debate, but for our purposes, we'll be just fine using the if-then statements. And most of the time, you'll be fine using the if-then statements. There's some reasons that in class, if you want to talk about, we can go over why I think that possibly that this doesn't work as well as it does. But one, I'd say it probably is, it sure seems like if you say if A then B, and remember we saw those little diagrams, right? And we said what this means is you can't be an A and be outside of B. If you're an A, you have to kind of be in B. Well, when we said these are okay, boy, are they okay? I don't know. I mean, it seems like this could be true or false outside of here, right? But I don't know. Maybe it's the way it's set up. I haven't solved the issue for myself for sure. So we could talk about it in class if you'd like to. That is the end of this video.